In October of 2017, astronomers witnessed something unlike anything they had ever seen before. For the first time in recorded history, an object from beyond our solar system was observed passing through it. This was not a comet or an asteroid from our own cosmic neighborhood. It had traveled across the vastness of interstellar space before entering our celestial backyard. The object was eventually named Oumuamua, a Hawaiian term meaning messenger or scout sent from afar, a name that perfectly captured the mystery and intrigue surrounding its appearance. From the outset, Oumuamua defied classification. Its behavior didn't fit the patterns of any known natural body. It wasn't shaped like the typical spherical or oblong asteroid. Instead, it was long and narrow, somewhat like a cigar or a flattened disc, depending on how it was observed. But what truly puzzled scientists was how it moved. Unlike comets, it showed no visible tail, no evidence of gas or dust being ejected, no sign of the usual outgassing that typically propels such objects. Yet it exhibited an unexplained acceleration as it moved away from the sun, an effect that couldn't be accounted for by gravity alone or any known physical forces. This combination of features made Oumuamua one of the most confounding mysteries in modern astronomy. Some researchers proposed that it might be made of hydrogen ice, slowly evaporating in a way that left no visible trail. Others ventured into bolder territory, suggesting that perhaps this was not a natural object at all, but rather an artifact, or even a probe sent by an intelligent civilization. While none of these hypotheses could be definitively proven at the time, the sheer novelty of the object kept the debate alive in the scientific community. Then, in December 2021, a powerful, new tool entered the scene, the James Webb Space Telescope. Designed to peer deeper into the universe than any of its predecessors, Webb is capable of observing the cosmos in infrared wavelengths, allowing it to see through cosmic dust and reveal objects in extraordinary detail. When Webb was directed toward Oumuamua, now well beyond the orbit of the outer planets, it delivered something extraordinary: the first high-resolution image of this elusive interstellar traveler. What Webb revealed was nothing short of astonishing. The object had a distinctly elongated, irregular shape, with surface features that included grooves, ridges, and craters, signs of a long and turbulent journey through interstellar space. These physical scars likely came from countless collisions, with tiny particles and micrometeorites as it drifted through the void for billions of years. But its appearance wasn't the only surprise. Webb's spectroscopic analysis, the way it reads the composition of objects by studying the light they reflect, uncovered an entirely different layer of mystery. The surface of Oumuamua contained complex organic compounds along with metallic and mineral elements that aren't typically found in our solar system. These findings strongly suggest that Oumuamua didn't originate anywhere near Earth's neighborhood. Instead, it likely came from a distant dynamic star system, one that formed and evolved under conditions vastly different from our own. Perhaps the most perplexing aspect of Oumuamua remained its unexplained acceleration. Webb's data finally ruled out the possibility that gas or vapor was pushing it forward, which left scientists looking elsewhere for answers. One theory gaining traction is the idea of a light sail, a theoretical propulsion system that uses the pressure of photons, or light particles, to generate movement. If Oumuamua is indeed being driven by such a mechanism, it could suggest an artificial origin, possibly the remnant of a spacecraft or a probe engineered to travel immense distances without fuel. Even more revealing was the discovery of a reflective substance on its surface. This highly reflective material could account for its strange brightness and irregular light patterns as it tumbled through space. Such material is extremely rare among known natural objects and points to either a very unique natural formation process or perhaps artificial design. Combined with the presence of elements that can form organic molecules, the findings hint at environments rich in chemistry and energy, ideal conditions for forming the building blocks of life. The implications of this are enormous. Some scientists now believe that Oumuamua might be a fragment of a planet that was destroyed under extreme gravitational stress, perhaps near a massive star or a black hole. These forces could have stretched and torn the planet apart, flinging pieces of it into the galaxy. If this theory is accurate, then Oumuamua isn't just an isolated object. It's a survivor from a catastrophic cosmic event, possibly the remains of a world that no longer exists. And now, billions of years later, it has wandered into our solar system, silently carrying the story of its origin. But beyond the curiosity of what it is and where it came from, Oumuamua might also play a role in a much larger story, the story of life itself. The organic compounds detected on its surface have reignited interest in the theory of panspermia, the idea that life, or at least the ingredients for life, can travel from one planetary system to another on asteroids, comets, or interstellar objects. Could Oumuamua be part of a natural delivery system, scattering organic material across the galaxy, and potentially seeding life where the conditions are right? It's a question that pushes the boundaries of what we know about life's potential, origins and distribution throughout the universe. And if life can be spread this way, it raises the possibility that Earth itself may have been seeded by similar means in the distant past. This line of thinking challenges our understanding of evolution and our unique place in the universe. It invites us to consider that life might not be rare but widespread, growing wherever it finds a hospitable home, perhaps even thanks to objects like Oumuamua. In many ways, Oumuamua is like a message in a bottle. It's a time capsule that has survived untold epochs of cosmic history. Studying it gives us insights not only into its own story, but into the wider processes that shape the galaxy, from how planets are born and destroyed, to how materials are distributed across vast interstellar distances, to how life itself might spread. The journey of Oumuamua touches on all these themes, and this is just the beginning. The insights gained from Oumuamua are laying the groundwork for future space missions that will attempt to intercept or observe similar interstellar objects. These missions could provide direct samples or even close-up images, offering new perspectives on the building blocks of the universe and the forces that shape it. Projects like Breakthrough Starshot, which aims to send ultralight probes to nearby star systems at a significant fraction of the speed of light, are no longer just science fiction. They are becoming part of our roadmap to understanding our cosmic surroundings. Oumuamua has changed the way we look at the universe. It's not just a mysterious rock, it's a catalyst for a new era in space exploration. Its presence has sparked conversations about extraterrestrial life, planetary destruction, interstellar chemistry, and the limits of what we know. And while we may never fully understand everything about it, what we've already learned has opened new doors. More than anything, Oumuamua reminds us that we are part of something much larger than ourselves. The universe is not a static place. It is alive with motion, change, and possibility. Objects like Oumuamua pass through our region of space, silent and ancient, carrying messages written in the language of stars, gravity, and time. And so, as we continue to explore, question, and learn, we are slowly beginning to understand what it means to exist in this vast and complex universe. Oumuamua is not the end of a story. It's the opening chapter of a much bigger one. What other secrets lie hidden among the stars waiting to be discovered? Only time and our relentless pursuit of knowledge will reveal the answers.